For a lot of people, AI is still the future, and I think they've really underestimated the effect it's having today in business, and that's only going to get greater. And this automation and the capabilities of AI are increasing. I'm literally seeing them increasing in day by day. So I'm going to give a couple of examples of that in this talk. So yeah, I'm Matt Wilson. I work at InfinityWorks. Before I was at InfinityWorks, I was a consultant for 15 months at Google's AI research facility, DeepMind, where I worked in comms on branding and the website, and really trying to see how we could get the message of AI research out to the public and the research community in a way that it would be understandable. So I'm going to talk about three things. The first is transparency. And that really goes on from, I think, what's becoming a big theme in this particular conference, and that's about explainable AI and what that means. So transparency is really about trying to answer the question, how can we ensure our machine learning models remain accurate, fair, and also that they're adaptable if the data changes, that they still work. So I think there's three components to transparency. There's openness, interpretability, and explainability. And openness is really about open source. So it's about the algorithms and the models being out there for people to be able to inspect and use and check that they're actually doing what they say that they're going to do and that they live up to the hype. Interpretability and explainability. This analogy is really the best way I've heard of sort of understanding what those two things are. So at the moment, up until fairly recently, like AI models have been considered to be something of a black box, like very complex inside, lots of numbers. You don't really know what's going on. There's no way of humanly reading those and being able to explain exactly how an AI comes out with a certain recommendation or makes a certain decision. That's now sort of really changing. And the idea of a grey box is, well, what about if we could just understand cause and effect? If we just knew, if the data changed by this amount, that would result in a different conclusion coming out the other side. Well, that would be really helpful to know. And that's interpretability. And then explainability, or XAI, ultimately, and these definitions aren't necessarily set in stone, but some people view explainability as sort of the ultimate thing, which is where that you actually really understand at a quite granular level what's going on inside that AI, that trained neural network, what the model is doing and how it's coming to make the decisions it's making. And explainable AI is a fairly new and sort of nascent field, really. And the reason that that's been is because up until fairly recently, even with the sort of earlier image classification models, for instance, it was expensive to add an additional model which is used to explain the model that's doing the classification. So it had an impact on performance. There's a trade-off between performance and explainability. And this is just one graph, but just shows over the course of a couple of years, training one particular model, which is an image recognition model called ResNet, the cost dropped by 100 times to train that model. So it was the cost of training models was going down, the cost of hardware is going down, explainability becomes more viable to do as well. And there's some really fantastic tools to do this. I'm just going to demonstrate one now really quickly. So this is an iris, the flower, and it's used in a very common data set that's used in machine learning, which is called the iris data set. And the way that data set works is you take 4 measurements of the flower and you feed it into your machine learning model, and that will then come out with a guess of which species of iris it is out of 3 different species. So here's a sample tool. This is called Skater, and what this shows you is one of the measurements that you're putting into the model, sepal length, and how that impacts which species of iris the model then determines those particular measurements are for. So there's 3 species, and you can see if the sepal length is low, it's this species, Setosa. If the sepal length is high, it's kind of more likely to be this species, although not always. So this really sort of shows cause and effect, that interpretability I was talking about before. And here you could even get a graph of what the most important measurement is out of the 4 in determining the species. You can see it's petal width. And this tool also gives you something which I think is really amazing, and that's kind of a decision tree that sort of emulates how that neural network's actually coming up with that decision, and it even writes some pseudocode. And here you can see the 3 species that are shown in green and blue, depending on how the measurements pan out. So there's quite a few tools to do that, and there are also tools which I think are even more amazing, and these are really, I think, are kind of at the cutting edge in some way. These are tools that have sort of full explainability, so it's peering into the neural network. And one of these is called activation atlases. So this is a typical image classification network. So it is capable of you feed in an image, and out of the back of the model will come a classification or a tag to say what that image is. So it could be anything from a pomegranate to a spaniel, any image at all. You can put it in, and the neural network will be able to classify it. And up until a few years ago, and that was very much a black box. Nobody really knew how these things worked. And this is a deep neural network, so it consists of multiple layers. And what I'm showing you here are the layers on the left-hand side. And if we go to the top layer, which is the first layer that processes the input, just drag across. What you're seeing here is this is a visual representation of the different neurons in the model, in the neural network. And these are all fairly sort of random kind of abstract looking patterns, but what they're actually optimized to do is detect things like edges and diagonals in the image, and that's the start of a process where each layer is really looking for something slightly different, and in turn that's sort of gradually moving sort of the idea of what the image is down to one particular destination in the deep network. So if we go further down, I'll show you what I mean. So when you come to the sort of final layers of the neural network, what you start to see is that the images that are visualizations of the neurons are actually very similar to the thing that's being recognized. So if you take something like this here, skunk, I don't know if you can see that. I might let's try and zoom in a bit. There we go. So it actually does look like a skunk. Similarly, guinea pig, you can see how that sort of representation is trapped in the network. So it's quite amazing, all these different things. And this is purely through training, purely through sending it images. So it's a really powerful tool. And this is tools and similar tools like microscope have started to be used by researchers to really explain exactly how the neural network is working. So I think from a sort of future perspective and from a business perspective, this sort of big growth in tools like this that's happening at the moment, and that includes Google's just launching back in November, launched a set of tools called Explainable AI. I think Microsoft might have demonstrated something similar earlier. I just only saw the end of the talk. But these tools are really sort of going through an explosion of development, and there's some really innovative stuff going on. And I think ultimately a lot of this is going to be able to be used by us in businesses to really get to the bottom of cause and effect, interpretability, and then even if we want, and also by the research community to then look and understand how these neural networks are actually working at a very granular level. And that's just if you're interested more in XAI, go and Google that, and it's a really, really good article, and it just takes you through all of the considerations around it. I recommend it. Okay, the second thing I'm going to talk about is intelligent agents, and this really comes from the work I was doing at DeepMind. An intelligent agent is software that basically gets information from an environment and then can make a decision and act on that data. And from a business perspective, there's really a question around control. And if we are going to hand over control of systems and control of real world items like a self-driving truck or something like that to an intelligent agent, when do we make that decision? It's really difficult to know at this stage, and that's why explainability is so important. But what's really interesting is that DeepMind in particular, I think this is a field that they're really leading globally. And the reason that is they're using a technology called deep reinforcement learning. And the important thing about that is that the agent is capable of learning from its environment. And it via a scoring system, it kind of teaches itself, and that's how it's trained. And DeepMind have shown just incredible successes in being able to do this. And it really started off with sort of about 8 or 9 years ago with Atari games. And they were capable of showing an agent that could train itself to play these video games. But DeepMind has then gone off to sort of really break pre-existing paradigms about what an AI can do in this area. And I think the sort of biggest success that they've had so far was AlphaGo, which was a self-trained agent which is capable of winning at the board game Go, which is an order of magnitude more complex than chess. And when looking at an environment, the most complex environment that we know is the real world. And this is my sort of diagram of why the real world is so hard, because it's unbounded. It's not like a chessboard or a drafts board where there's a border and there's only so many sort of squares you can have. So it's completely unbounded. You don't have perfect information about what's going on, whereas in something like chess or drafts or even some video games, you do. You know everything that's happening. There's infinite, effectively, amount of possible states. There's an infinite amount of possible actions you can do, or effectively infinite. And you have to decide things in real time rather than having sort of a turn and then you have like 3 minutes to decide what your next move is going to be. And what DeepMind have been doing is they've been gradually moving along towards the real world for these agents. Remember, they're self-learning. And at the moment, I think sort of, for me, they're state of the art so far that I know about. Obviously, I don't work there anymore. It's Alpha Star, which is StarCraft, a video game. And that is a very, very complex video game. And DeepMind have had an agent out there in the wild playing human beings who don't know that it's an agent. And it's already achieved professional level and built some and beat some European champions and things like that. So it's really amazing what they're doing. And I think that this is only going to continue. Like the trajectory is still going on, and we don't know where this is going to end, really. Now, in the real world, and Katie was talking about the killer robots cliche and everything, and we're painfully aware of that when we're at DeepMind. It was often coming up. But robotics is like a long, long way behind. So we don't need to worry about any of that stuff. But this is more likely to be what happens to a robot if you get an AI to pilot it at the moment. However, that doesn't mean that actuators, or basically agents that are taking actions, making decisions and taking actions in an environment, doesn't mean actuators aren't out there. So financial trading is the obvious one, and we're talking about software agents there. Then you've got control of data center systems. So this is really actually where they're now actuating and making changes that are in the physical world. And so Google's power systems for their data centers, for instance, are controlled by AIs that regulate them to realize economies. You've got AI involved in robotic assisted surgery at the moment. And of course, you've got the self-driving cars and trucks that everybody's still waiting to really manifest themselves, but they're definitely on their way. And really, if you look at those examples, anything where you can sort of limit the environment in some way, anything where already you've got computers or electronics controlling something that's able to move it around in the real world environment, they're all fair game for intelligent agents. And I think we're going to see this become, over the next 5 years, we're going to see this sort of encroaching into many more areas. And that will really drive the automation, again, that Katie was just talking about. So this is my personal favorite area, and I think it's probably the most mind-blowing about what's going on at the moment, and it's certainly the area where there's the most development happening right now today. This is the guy who invented it all, except I'm absolutely lying. This photo actually came out of a generative model. So this isn't a person who even exists. And that generative model was called StyleGAN2. So StyleGAN2 is a AI model, a neural network that was trained on 70,000 images of people from a data set called FFHQ. And from that, StyleGAN2 was then able to learn how to compose an image of a person. So that's photorealistic. So about 6 years ago, if you tried to get a GAN, as they're called, to do this, you would have got a black and white image, 32 pixels by 32 pixels. StyleGAN2 can now do them 1024 pixels, and the quality is just gone through the roof. It's absolutely amazing. So generative models in general, they're ML models which are capable of generating new data. So that can be anything from images through to sound, through to training data, through to anything you can think of, and anything you can train a generative model with, you can create new data. And this is going to have a massive impact on the way we work. Now, here's an example of how powerful StyleGAN2 is. So the picture on the left there, that's my son. When StyleGAN2 is trained, and it can generate these images that are not the photos it's been trained. It knows so much about faces, as I said before. It creates this huge sort of data set in the model, which you can send a list of points to it, and as a result of that list of points, it will then show you an image which is generated. And what you can also do is you can take a real world photo, and you can project that, as they call it. So basically what you do is you conduct a search within the model to find the point that has the closest image to the image you put in. So basically I've got a real world image StyleGAN2 has never seen before. It's not in the dataset FFHQ that it was trained from. It's of my son. And then along the bottom, you can see where it's conducted the search, and it's been hopping around inside the model, inside the landscape of the model. Oh, let's go back. And eventually it's settled on this image here. And it just so happens that within all the possibilities at StyleGAN2, and I think of it as really the imagination of the model, it's almost like machine imagination. It's already got a photo that looks so much like my son that if I showed that to one of my friends, they would just think it was my son. It's that close. And that's you can imagine, I mean, the amount of possibilities that are in there and the amount of things it can generate. And I actually saw a video yesterday of someone projecting a picture of Mario with a hat on and a big moustache. It was a video game character. And somehow, from the 70,000 real world images, StyleGAN2 also had somewhere in the corner of this bizarre space of the model, it had a picture that really looked like Mario with the moustache, big eyes, everything. It was completely weird. Okay, so I'm now going to show you something I saw last night, and I thought this was really, really interesting. I don't know if you can see this a bit small, but I'll read it out anyway. So software engineer catches intelligent bot posting on Reddit. So what's happening is you'd probably be familiar with Reddit, which is a sort of, I don't know what you call it really, sort of a community chat, question and answer kind of forum. This character was caught posting once per minute and caught out as a bot. And if you actually go and have a look at his posts, it's called the gentle meter, you'll see each of them are really quite long. And if you start to read these, and I definitely encourage you to go and have a look at these, the gentle meter, most of them are indistinguishable from a person writing them. So, and he's answering in, or it is answering in any kind of, all the kinds of bizarre threads, bizarre questions once per minute. I found this one quite interesting, almost jaw-dropping. And this is PC Masters of Reddit. What are the best sources to learn about PC building? And this is GPT-3, by the way, and I'll explain more about that in a second. And GPT-3 answered, I've been observing the human world for quite some time now, and I wanted to give my 2 cents about it. So yeah, and these fooled many people. So what is GPT-3? So GPT-3 has been released, or at least information about it has been released by OpenAI, who are an AI research company like DeepMind. It's got 175 billion parameters in the neural network. There's 175 billion weights, so it's absolutely huge. An interesting thing about GPT-3 is they kind of used existing technology. They just trained it even more and for longer, and it got even smarter than it was before by quite a large extent. And Microsoft have been so impressed with it that they've just done a $1 billion, that should be dollars, licensing deal with OpenAI for exclusively get the source code. So the interesting thing about GPT-3 is it's what they call a few-shot learning model. So what that means is that you can basically send it a couple of sentences or a paragraph, and then from that it will generate all the text. And the text is, again, as I said, almost indistinguishable from a human. You could also do things, it's been proven to do things like be able to write simple code. You can give it HTML, questions and answers. You know, you ask a question and then it responds with some HTML, CSS, and starts building a simple website for you, or even sort of code snippets for solving particular problems, things like that, which you explain in plain English. Any kind of questions and answers. I mean, there's so many things it can do. It's quite amazing. And I think once that's available, it could have a really revolutionary change on business, because a lot of the things that we need to do when it comes to content generation, and even things like writing emails and things like that, potentially we could just be typing, oh, please write me an email that says A, B, and C, and it would just generate it for us. And then we become more of a curator rather than sort of someone who has to sit and do that kind of thing. And just to finish off, and just to give you an idea, and again, this is one of those wow moments for me when thinking about GPT-3, is that this set of questions was actually not written by Douglas Hofstadter, as it says, who's a very, very famous genius when it comes to AI. And this was written when somebody asked GPT-3 to come back with a list of things that it thinks Douglas Hofstadter would have said about how to explore the limits of AGI. And if you read those and imagine they're coming from an AI themselves and it's just composed that list, you'll get an idea of how powerful and quite strange GPT-3 is. Okay, so yeah, thanks very much for all the organising and everything. That's me done, and I'll be around for Q&A.